that down. Do we remember what a variable is? It's a letter, hey? A variable is a letter. So like you can see here, we have x's now. We have an x there and an x there. So guys, I want you to understand that we're going to use the same methods that we used when we were just working with numbers. All right, but now we must remember, what do we know about algebra? About what did we do before with adding and subtracting? We can only add and subtract like terms. Do you remember that? Okay, so I'm just going to add that here to the heading. Add slash subtract like terms. So guys, we're basically putting together two topics now. Actually, possibly even three topics. All right, we're putting together fractions. And what do we do when we're adding and subtracting fractions? We need to remember that. Then we're putting together like terms. We need to remember that when we have x's and y's and whatever, we can only add or subtract like terms. And then sometimes there's going to be negative numbers as well. All right, adding and subtracting negative numbers. So that's actually three topics that we can put together now. Okay, for this one, guys, what do we do when we add and subtract fractions? Want to give someone else? Yes, Andre? It's the same denominator. Okay, we need to find the LCD. What is the LCD of 5 and 3? 15. The LCD is 15. So we need to change both of those denominators to a 15. 5 multiplied by 3 is going to give me 15. So then I must do the same thing at the top. For my second fraction, 3 multiplied by 5 is going to give me 15. So I must do the same thing at the top. As we haven't done anything new, right? We've been practicing this, adding and subtracting fractions. We need to get the denominators the same. Now, when we're saying 2x times 3, right? What is 2 times 3? 6, and then you just have that x next to it. Okay, so 2x times 3 is just 6x. That's new, right? But you just multiply the numbers together, and that x stays there. That is over 15. Plus 4 times 5 is 20, and then that x you just need to write next to it. 20x. 4x times 5 is just 20x. Okay, so you still multiplying numbers together as we did before, and that is also over 15. Now we can add them together, right? But before we add them together, we need to just first decide if these two are like terms. 6x and 20x. Do we remember like terms have the same exact variable, the same letters? 6x and 20x, they have the same letters, right? So these are like terms. I'm going to write it on the side because we haven't done a lot of practice on this stuff. So 6x and 20x are like terms. Therefore, can add them. You'll see in the next question what happens when they're not like terms and how we then need to write our final answer. Okay, so now we're going to say 6x plus 20x, 26x. That's it. You just add the numbers like you normally would, and you just have that x as a part of your answer. 26x over 15. Now, guys, you just need to ask yourself, is there a number that divides into 26 and into 15? No, right? So that is the simplest way. If this was 25 and 15, you would have had to divide both of them by 5. Okay, so if you can simplify the numerical part, the numbers in that fraction, then you have to do that. Okay, but exact same fraction method. We're doing the exact same thing. The only thing that's added now is we need to look for like terms. Okay. Next example, x over 2 minus y over 8. You can write that down, please. Okay, we are now subtracting one fraction from another. So again, we need to find the LCD. The LCD of 2 and 8, the smallest number that 2 and 8 divide into, yes, okay? 8. So now 2 multiplied by 4 is going to give me 8. So I'm going to do the same thing at the top. And my second fraction, that's nice, that's already over 8. So I don't have to do anything to the second fraction. All right? So my first fraction is going to become 4x, right? X times 4, we're just going to write that as 4x. Over 2 times 4 is 8. Minus y over 8. Now that we can subtract these fractions from each other, right? Because they have the same decimal. But 4x and y, do they have the same variables? No. So now 4x and y are not like terms. Therefore, we actually can't add them together. But I'm going to show you what we're going to do. Therefore, cannot actually subtract one from the other. I'm moving across this now. So we cannot subtract one from the other, right? We can't get an answer if we say 4x minus y. But we have the same denominators. So we are actually just going to write that as one fraction instead of two separate ones. Okay, so I'll show you now how to do that. But we can write the answer as one fraction instead of two. Okay, so what am I doing at the top, guys? I'm saying 4x minus y. Now, even though we can't get an answer for that, we can still write that all over one denominator of, I think keeps freezing, it looks like, all over one denominator of 8. Okay, so if they're not like terms, you still have to write it in one fraction, please. Right? They say you must subtract the one fraction from the other one. You're supposed to get one fraction as your answer. Okay, so that is what you do when they are not like terms. Example 3, let's write that one down. That's the last one that I'm going to do with you. Then you're going to practice some on your own. Now, guys, I'm going to just different color highlighters for this. This 1/3 b that we have, we are not going to leave it like that. Okay, I want to write it as a fraction. That's almost like a mixed, I don't want to say a mixed number because b is not a number, but that's like a mixed fraction, if we want to call it that. Okay, we want to get it as something over something. All right, I don't want the fraction and the variable next to each other like that. So let's just make a note on the side here. I'm going to use the same color highlighter to make a star, just to show you that we're going to simplify that. We're going to write it differently. Now guys, 1/3 and a b, that actually means a third times b. Okay, so 1/3 b actually means 1/3 times b. Now guys, do we like multiplying things together when they're like that, when it's a fraction and like a whole thing? We want to do a fraction and a fraction, right? So b I'm going to write as b over 1 instead, because then I can apply my fraction multiplication rules. Now we're going to say 1 times b is just b, right? 1 multiplied by anything is just that thing. 1 times 5 is just 5. 1 times 7 is just 7. So 1 times b is just b. And at the bottom, we have 3 times 1, which is just 3. So that instead of working with a third b, we're going to work with b over 3. Because I'm adding and subtracting fractions here. Hey, so I just want fractions for all of them. I don't want mixed stuff. So this 1/3 b, I'm going to rewrite as b over 3. So I'm going to do that in the next line, b over 3. So guys, you can kind of do that by inspection, right? You don't actually have to do this working on the side, because if you're looking at this, 1/3 b, you see that I just put the b at the top. Okay, you can actually just do that, right? You're allowed to do that. You can just remember that it's a fraction and the variable next to the fraction. You can just put the variable at the top of the fraction. Okay, we'll always work like that. Yeah?
So man, today,
Over 3. Yes, so you can just put the variable at the top. Okay, guys, what about 2a? How can I write that as a fraction? Yes, 2a over 1. 2a over 1, just like we did with numbers, right? If we just were adding a 2, we would say let's write that as 2 over 1. Same thing. Okay. Now this one here, I'm just going to circle this again. And we'll do a circle star there on the side. 3 over 4a. Instead of writing it as a mixed fraction like that, I'm going to change it to 3 over 4 times a over 1. And do you guys see what's going to happen? The a is just going to go to the top. Because 3 times a is just 3a. And 4 times 1 is just 4. So like I said before, you don't actually have to even show this working. You can just remember if it's a fraction and a variable next to it, the variable is just going to go to the top of the fraction. Okay, you see that with 3 over 4 and a, and then it becomes 3a over 4. Okay, so that is what's happening there. But guys, if you forget that, you can do the calculation on the side. There's nothing wrong with that. So this is now minus 3a over 4 plus 2b over 12. That's already a fraction, right? So I'm just going to rewrite it as it is. Now we have 4 fractions that we are adding and subtracting. We need to find the LCD of all 4 of these denominators. 3 and 1 and 4 and 12. Do we agree that it's 12? Okay, good. So the LCD here, if you have space on the side, you can write it on the side. Otherwise, maybe just make an arrow somewhere and write LCD for 12. So if I look at my denominator, yes? Can if you want to, but we can also do that later. All right, so to turn 3 into 12, I need to multiply it by 4. I'm going to do the same thing at the top. The next one, 1 times 12 is going to give me 12. So I must do the same thing at the top. The next one, 4 times 3 is going to give me 12. So I must do the same thing at the top. And the last one is already over 12, which is the LCD. So I don't have to do anything to that last fraction. Okay, now we can just work that out. B times 4 is 4b, and that is over 12, plus 2a times 12. Guys, you just multiply the numbers together normally. 2 times 12 is 24. And then you put the a next to it, so 24a. Minus, there's a minus in between those fractions. Again, we're just going to multiply the numbers. 3 times 3 is 9. And then we put that a there, so 9a over 12. And then plus 2b over 12. Now we're going to look for like terms, right? All of these are not like terms. We agree, all 4 of them. They're not all 4 like terms. But we have a 4b and a 2b that I can put together, right? 4b plus 2b is what? It's 6b over 12. Remember when we only add the numerators together, the denominator stays the same. And then let's look for our a's. We're finding like terms now, right? 24a minus 9a. What's 24 minus 9? 15. So it's going to be 15a, right? Is it positive 15a or negative 15a? Positive, right? I'm saying 24 minus 9. That's an answer of positive 15a. So it has to be a plus 15a over 12. Okay, what did we do in the previous question? Yeah, okay, put it all over one fraction. Put it all over one fraction, okay? Even though I can't add these two together, they still work over 12. I have to write it as one fraction. So we can say 6b plus 15a over 12. Now guys, that is not my final answer. Why not? I'm going to give everyone a chance to think a little bit. I'll pull on the denominator. Why do we think that is not the final answer? Just everyone look at it and think, can we maybe simplify that? Yeah, I'm going to ask someone else here because you've spoken before, right? I can simplify the 6, right? And what about the 15? I can simplify both of them. Guys, did you do splitting up fractions last year? Some of you did, hey? It seems a bit counterproductive because we just had 2 separate fractions and then we put them together as one, right? But now I'm telling you, you must split them up again, which is a bit strange. How did you want to ask something or say, oh, no? Hey, yes? You could, it doesn't really matter. It's just in one term. They have to be in alphabetical order, but like that, it's a separate term, so it doesn't matter. Now, guys, I'm actually just gonna do it like this. We're looking at both of all 3 of these numbers, right? What number can divide into all 3 of them? It's 3, right? So guys, if you want, you can't just say, okay, 6 and 12, I'm going to simplify that, I'm going to leave the 15 as it is. You're not allowed to do that. Okay, if you have multiple terms at the top here, you need to simplify all of them and the 12. All right, how many times does 3 go into 6? 6 divided by 3 is 2. 15 divided by 3 is? Oh, what am I doing? Sorry, I wrote a 3, I meant to write 5. There you go. 12 divided by 3 is 4. You have to do it with all of them. Guys, if this was 10, no, that's a bad example. If this was 11a, that was 11a, you couldn't do this. Okay, the number, you have to simplify all of them. All right, you can't just do the 6 and the 12 or the 15 and the 12. You have to do all of the numbers that are, all right, all of the terms. So now what is this going to give me? 2b plus 5a over 4. Now that's fully simplified. Okay, guys, do you notice this is what I'm talking about? With the 2 and the 4, right? Those have a common factor, but does 5 have that same common factor? No. No, so I can't simplify. Okay, when you are simplifying like this, you have to simplify every single term. Okay. I am going to put up a worksheet for you on the screen quickly because I just have to run and go print it. You can start working on it so long. Let me just get it here. Hmm? Yeah. Okay, so guys, this is called algebraic fractions worksheet. You can make that heading. Please, Laura? Yeah, I'm just taking the class. Okay, guys, there you go. Right first, you can just start working on those quickly. Can you read that? Maybe I'll zoom in a little bit. Okay, is that better? So guys, please write this is your heading, algebraic fractions worksheet. And then you are doing, you can do the first 4. Just check, can you read what those numbers are? Algebraic fractions worksheet. Did you write that down, please? Because I'm going to move down now, then you won't be able to see it. Algebraic fractions worksheet. Yeah, you write the question and then equals, and then you get to the answer. And guys, see they saying in the heading, write your answer as one fraction. Okay, that's what we did in the example. Okay, so you're going to start working on that. I'm just going to go print a copy of this for each of you.